In this lecture, let's understand how to extract the SVC number. Because once the SVC exception handler runs, it has to know the SVC number which is requested by the user task or the thread level code. The SVC instruction has a number embedded within it that is often referred as SVC number. In the SVC handler, you should fetch the opcode of the SVC instruction, and then you have to extract the SVC number. How do you fetch the opcode? Opcodes are stored in program memory. So that's why to fetch the opcode of SVC instruction from program memory, we should have the value of the PC, that is return address, where the user code had interrupted while triggering the SVC exception. That means we should have access to the past PC value where the user code had interrupted while triggering the SVC exception. The value of the PC where the user code had interrupted is stored in the stack as a part of exception entry sequence by the processor. All these points may look confusing. Don't worry, I have an animation for you. Let's understand this with an animation. Let's say that is a task or your thread level code which is running, and you execute the SVC instruction. At this point, SVC instruction is executed, and that triggers the SVC exception immediately, isn't it? This is a stacking. A stack frame will be stored in the stack memory, which is pointed or traced by the MSP. After that, what happens? SVC handler runs. This is thread mode, this is handler mode. In the handler mode, what you should do is you should get the value of this MSP. You can get that. You can use some inline assembly code in order to get the value of the MSP. And after that, you have to do +6. When you do +6, you get the value of PC. This is the return address to go back to the thread mode, isn't it? The PC was pointing to this value when the user task had interrupted by using the SVC instruction. And after that, you just stored the value of the return address into a variable. This variable now has the address which was pointing to the instruction right after the SVC instruction in the thread mode. And after that, you have to do -2. That's because you have to come back to the SVC instruction opcode, isn't it? Because the address which is stored in this variable is pointing to the next instruction after the SVC. That's why you have to do -2 here in order to extract the opcode of the SVC instruction. And by doing that, we get the SVC number. I know it is confusing, and don't worry, so when we do exercise, I will explain it better. But the key point is this one. In the handler, you should get the value of the MSP and then move that pointer by 6 and get the value of the return address. And by using that return address, we can then extract the SVC number. Let's do an exercise. The exercise is very simple. Write a program to execute an SVC instruction from thread mode. Implement the SVC handler to print the SVC number used. Also, increment the SVC number by 4 and return it to the thread mode code and print it. Here I give a couple of hints. First of all, what you should do is write a main function where you should execute the SVC instruction with an argument. Let's say SVC 0x5. You should do it using inline assembly code. After that, implement the SVC handler. In the SVC handler, extract the SVC number and print it using printf. And after that, increment the SVC number by 4 and return it to the thread mode. Try to do this, and I will cover this exercise in the next lecture.